Yes. Hi, my name is Christina Maldonado, and I will be giving a presentation on VHSIC hardware description language. I'm just going to start with a brief introduction. The U.S. Department of Defense sponsored a project to develop very high-speed integrated circuits, aka VHSIC, and that was in the 1980s, I believe 1985. And the purpose of VHDL was to have a standard language of documentation for electronic systems proposed to the United States government. VHDL is similar in style to Ada, and understandably so. Ada was also sponsored by the Department of Defense, and the goal of Ada at that time was to supersede the many programming languages in use at its introduction. And when compared to acceptance of the language, unlike Ada, HDL quickly rose as a language to become an industry standard, due in part, by the backing of DoD, but also there was the lack of competing languages. As part of the industry standardization efforts, all rights to VHDL were given to IEEE. The original version developed by DoD, version 7.2, was changed substantially to encompass a broader scope. The developed version was recognized in 1987 and became a requisite deliverable for all DoD military electronic contracts. Since being turned over to IEEE has been revised a few times, and the most recent revision was released in 2009. In addition, many supplemental standards have been released to accompany VHDL. And, we have packages like math packages, synthesis packages, multi-value logic. And there we have a reference to the latest. The latest was also released in February of 2009. And VHDL has many features that can be implemented in similar fashion to that of programming languages. We have things such as block statements, functions, processes. We have control statements, which is a big one. VHD is strongly typed, and it is also a data flow language. Many of these features are designed for the end mean of describing hardware in the most explicit and intended way possible, and that's the reason for the strongly typed. The data flow is, because it is inherently a hardware description language, and that is the nature of hardware. VHDL includes statements such as if, loop, return, case, next, exit, and wait, and it includes all operators which behave as would be expected. Here we have a simple example of operators. We have a full set of operators for arithmetic and comparison operations, not, NAND, or, nor, equal, etc., etc. We also have the arithmetic operations like the basic ones, plus, minus, times. We also have some added ones for absolute values and mod. High order of precedence is followed in VHDL, and it would be as expected. Multiplication goes first, etc., etc. Bitwise operation is available, and this is specific to VHDL because it is used to describe hardware languages, and hardware does work with signals. There are two types, basic types and synthesis types. Booleans, we have booleans, bits, character, security level, positive, int, real, time, string, pretty much everything. And for synthesis size, it would be a synthesis size because it can be any number of size can be created. And this is great for RTL synthesis, real time. Entity and architectures, this is a big thing in VHDL. The entity is the interface to the circuit, and the architecture is what defines the circuit. And we have to have both of those to run a VHDL program. We will go through an example where we will see that entity in architecture. So you'll see what I'm talking about in that sense. And it is necessary for the VHDL. And then here we have a while loop example. And this simple illustration shows a while loop that iterates per a specified number of times before ending. We see the use of the equal operation here. And then we also have a plus, and it would act as you think it would act. And it's really simple, and you see the use of labels, and it's pretty intuitive. It's not that difficult. Start at 0, count up. When you hit number 3, then you would exit out of the counter, out of the loop. So yeah. Alright, let's move on to VHDL and parallel programming. One of the advantages of VHDL, it can be used as a general programming language, so it can represent parallelism or concurrent systems. It's a data flow language, a language in which the data is passed from instruction to instruction. In comparison, a procedural language the data doesn't move with the instructions, so you can only represent one instruction at a time. Parallel programmers make use of the parallelism features developed for the inherent parallelism found in hardware. Some examples of these parallelism found in VHDL are the indexing of the arrays. You can index it in ascending or descending direction. And we also have a thing called parallel transfers. And parallel transfers allow execution of several operations simultaneously during a clock cycle. So let's now move on to can we use programming languages for hardware description? VHDL has many language features that a programming language would have. As stated before, we have data types, function, procedures, and control statements that can be represented in programming languages. We see here the example that we had earlier, the while loop. When transcribed into the C language, it would actually be really simple. So we have the initializing the n to 0, while I is less than or equal to 3. We go into the loop, we do whatever it is you want to do in the loop, and then we increment it. So this translates to this. So it's really easy. Based on this simple example, you would think that you can use programming languages for hardware description, but then it comes to the big point. Can you use it to represent parallelism? And like I mentioned earlier, most programming languages are sequential, so it's one instruction at a time, which equals to only one path through the circuit at a time, and this is as many times, or as very common, not always the case in hardware. So you can theoretically use it, but would you? No. Let's move on to simulation and synthesis. Since the introduction of VHDL, it has become the vehicle of two main but varying goals. It is used frequently in the simulation of electronic designs and also the synthesis of these designs. A system's hardware is ultimately constructed from the connection of the smaller components like adders, LIUs, flip-flops, latches, and multiplexers. Electronic designs can be achieved with the use of the VHDL, namely because it allows for the design of these small components. Now, VHDL is capable of synthesizing larger systems given the accuracy of representation of these small components. This is an example of a full ladder. And earlier I mentioned that we would talk about the entity and the architecture. Here's an example. So this is the interface. We have a port where you can accept 2 variables, and it spews out 1 variable here. So this is the interface, and this is how you would actually implement it. You A XOR B XOR sin, and this is what you would output. And this is a block statement. We begin with a begin statement, and then we end it with an end. This would be like the header, the prototype header. It's not too difficult to understand. The only thing you would have to remember is that you do always have an entity and an architecture in order to be able to work with VHDL. And the newest VHDL standard, including the extension of logical and numerical types that were not encumbered by bitwise operations. And the extension was standardized in the name of adding RTL synthesis capabilities and, thus ensured VHDL a place in modern description languages. Okay, well, I'd like to conclude this presentation. VHDL, I believe, is poised to continue being a popular hardware description language. Although it can be used to represent both sequential and concurrent programs, it should only really be used for what it was intended to be used as, aka hardware description languages. Likewise, we can take, for example, a programming language like C and use it to describe some hardware. But would we really want to do that? Not really. So it is best to use what each language was intended for use in order to take advantage of each language features and optimize it. It is optimized for its intended use, so why not go ahead and use it that way? And that was my conclusion. I hope you enjoyed this presentation. I also want to give credit to the great folks that helped me along my way. Thank you. Once again, my name is Christina, and have a great day. Bye.